Hello everyone, I'm Mehmet Alkuş. In this video, we will solve one problem in chapter 23. You are given two concentric spherical metal shells. A positive charge capital Q is put on the bigger shell and a positive charge Q on the inner shell. A. Find the magnitude of the electric fields everywhere. If we draw the radial distance r, which is measured from the center, for the region where r is less than a, if we draw a Gaussian surface enclosing this region, and if we put an eye in this region, we see no charge. Therefore, the electric field in this region becomes 0. For the region where r is greater than a and less than b, that is the region between the shells, if we draw a Gaussian surface enclosing this region, and if we look at inside the region, we see only the charge of inner shell, which is Q. According to the shell theorem, this charge can be considered as if it is concentrated in the center. As a result, the electric field is found by K times Q over R squared. Finally, for the region R is greater than B, that is outside the spherical shells, if we draw a Gaussian spherical shell enclosing this region, and if we put an eye in this region, we see the total charge capital Q plus Q. According to the shell theorem, this charge can be considered as if it is concentrated in the center. Therefore, the electric field is calculated by the formula K times capital Q plus Q over R squared. B. Find the inner and outer charge distributions. If we label the inner and outer shells as 1 and 2, and if we label the inner surface charge distributions as Q1i and Q2i, and outer surface charge distributions as Q1O, Q2O, for shell 1, according to the shell theorem, all the charges are distributed through the outer surface of the shell. Therefore, Q1i is 0 and Q1O is Q. For shell 2, if we draw a Gaussian surface inside the shell, and if we look around this region, since there is no charge inside this region according to the shell theorem, and because outer charge distribution of shell 1 is positive Q, then the inner surface of shell 2 is deposited by charge negative Q. Finally, if we draw a Gaussian surface enclosing shell 2, and if we look inside this surface, we see a positively charged outer surface. In other words, outer charge distribution of shell 2 is the total charge of the system, that is capital Q plus Q. Okay, we are done. Thank you for your attention. See you in the next video.